Hi, I'm Polita Paulus, and I'm going to show you some of the new features of Windows 8.1 Store apps built using HTML with Visual Studio 2013 today. To start, let's look for a minute at the architecture of a Windows Store app built using HTML. Starting from the bottom, Windows is, of course, our platform and gives us access to great features of Windows, such as devices for things like geolocation, the file system, and great touch interaction. Through the Windows RT on the right there, you can access Windows directly in your app. HTML apps use IE's rendering engine, Trident, to interpret and draw HTML, CSS, and JavaScript. This is the same engine used by IE 11. HTML, CSS, and JavaScript languages lay above, giving us a document object model, a layout model, styling, and dynamic typing. Again, we're using the very same engine that IE 11 uses for these. WinJS is a library written entirely in JavaScript to give you common utilities, look and feel, and controls that match Windows. On top is your app, using HTML, CSS, JavaScript, WinJS, and WinRT to do awesome, innovative things. For much of this presentation, I'll focus on the features in WinJS. If you built an HTML app for Windows 8, you used WinJS 1.0. If you are building an HTML app for Windows 8.1, you'll use WinJS 2.0. The features we'll talk about today are all part of WinJS 2.0, but built on top of everything delivered in WinJS 1.0. In other words, if it was there in 1.0, it will be there and improved in WinJS 2.0. Across the HTML application stack, we did significant work in Windows 8.1 to make apps better. First, we focused on speed. Next, we added more controls to support UX patterns. Lastly, we worked on developer productivity features to help you build and debug your apps more efficiently. I won't get to all the new features today, but we'll talk about the features in yellow. Our flagship new control is the hub control. The hub pattern has been an essential design element since Windows 8, and now you can build it easily into your app. A hub lets you declare sections with curated, heterogeneous content. The hub pattern is used by many apps, including the Games app, the Food and Drink Hub app, the Store app, and the Reading List app. Now let's take a look at how you can build a hub into your app using Visual Studio. I'm going to use the File New Project menu to create a new hub application. This is a new template that we included in Visual Studio 2013 to help you create an application with a hub. I'll call mine San Francisco. Visual Studio is going to create a complete project for me that includes a hub and all the files I need to create my hub project. You can see right away it's got a reference to WinJS 2.0 and all sorts of files that I can use to customize my application. Let's run it and see what we get out of the box. Right away you can see that I've got the classic hub pattern with many sections, and on the far left is this big gray box, which is the hero image. We're going to want to customize that, and then we'll customize some of this section content. So let's go back to Visual Studio and get started. First thing we want to do is change out that hero image. I do that by customizing my hub styling. Right here in my hub is my hero image styling, and the background image points to gray.png. I want to use my own image for that, so I'm going to add an image to my project. And on my desktop, I have a beautiful picture of the Golden Gate. So now that it's added to my project, I can point to it just by supplying its URL. And let's rerun. Great, now we've got a beautiful image of the Golden Gate Bridge. It's still not our section content quite yet, but it's starting to look a little more like ours. Let's customize it a little more. If we go into the hub page, we'll see that we have this hub control, and within the hub control section is the one that we just modified to have our hero image. We'll go ahead and keep that, but all these other sections that we saw when we ran it, they're samples, So I'm going to go ahead and remove them. Great, now that they're gone, what we're left with is a hub and a hero image. Let's add a new section with our own content. I'm using hotkeys so you don't all have to watch me type. But what we added here was a div and declared it to be a hub section control using DataWin control tags. And in the DataWin options, I said its header is going to be static, meaning I don't need people to click on it, and the header title is going to be transit map. Now let's go ahead and put a map in here using a simple image tag. Great. Now let's run it again and see how it looks. Just that simple. We have something that's starting to look a lot more like a classic hub. Another control that we added in this version is the repeater. And the repeater is a really great way to do simple data-bound lists. For many of your lists, you're going to use the list view, which has great features like entrance and exit animations, selection mode, and flexible layouts. The repeater is a much simpler control that'll just stamp out the data-bound controls for each item in your data source. Let's go ahead and use that control to display my favorite restaurants. I'm going to add a new section with a repeater that has a list of the restaurants that I visited and the ratings for them so that I know exactly which restaurants I've liked so that I can go ahead and revisit them later. Let's add a repeater section to my page. What I added here is another hub section control. And again, our header is going to be static, meaning it's not clickable, and the header is going to be restaurants. Inside, what I've added is a repeater control on this div. And inside the div is a container that contains two additional controls. A rating control, which will let me show how much I liked a particular restaurant, and another div that'll have just the name of the restaurant. We haven't quite data bound these though. This is just the layout of a single item that I would like to have repeated. Let's go ahead and data bind these. On the rating control, we'll add a DataWin bind attribute, and then we'll bind winControl.userRating to the rating property of our data source. And on our empty div here, I'd like to show the name of the restaurant. So we'll add a DataWin bind statement. And we'll bind that to the name property of our restaurant. One more thing, we actually need to add data to this repeater. So on the repeater, we'll do DataWin options. And we'll bind the data to our data.restaurants property. This should look great, but now we actually need to provide this data. Let's go into our code behind file. We'll add some data. Now you can see under the data namespace, we're adding several new restaurants, each with a name property and a rating of how I liked it. Now I'm going to add some UI for my users to add a new restaurant. What I've added is a box for them to add the name of the restaurant, the rating in a drop-down list of different ratings, and a button where they click. We now call that add restaurant method that we just added. Let's go ahead and run it. And we can see now that our repeater control has rendered the ratings above in these nice little stars and the name of each different restaurant that I've already added ratings for below. And I can add a new rating. And we'll give this one a 5. And right down at the bottom, our repeater control recognized that there was a new item in our data list and automatically updated our repeater. The list view is one of our most commonly used controls. We did a lot of work in the list view to improve it. Performance was our first concern. On the left is Windows 8 with the March mail update and all the latest Windows 8 updates. On the right is Windows 8.1 with the Windows 8.1 preview mail client, which is the March update retargeted for Windows 8.1. You'll see that the startup time is better and panning is significantly improved, and you can no longer see those gray backdrops as people pan. This is a significant set of performance improvements for your users, and things like those gray boxes going away will be definitely noticed. We also built a more flexible layout system. We've included several new layouts. Vertical grid layout lets you build a grid that scrolls vertically in addition to the list layout, which has always supported vertical scrolling. The list layout now supports grouping and headers. And the cell spanning layout lets you design a puzzle piece type layout with items that span cells. Or you can build your own layout by implementing iList Layout 2. For instance, our team built a sample circular layout in less than 100 lines of code. As part of our performance-focused work, we built a single system-wide scheduler into WinJS 2.0. Because apps are largely asynchronous, it can become hard to prioritize work against other work in the system. WinJS has a set of work that it does on your behalf, such as laying out controls or responding to user input. The system does work as well, such as processing touch events. Some of those are important tasks, and some are less important. Without the scheduler, those are handled in an unpredictable order, which can cause responsiveness issues for your applications. With the scheduler, all tasks are assigned a priority in the system. AppCode can choose the relative priority within the system, and tasks are guaranteed to run in priority order. Let's take a look at an example of how the scheduler can be used in Visual Studio. I'm going to start with a blank app. And we'll call this our scheduler demo. And the blank app has given me some code in the app on activated event handler. I'm going to remove it all because we're going to add our own code. And let's just add some tasks to the WinJS system scheduler. To make things a little bit easier, I'll use a namespace. Now I can use my S variable to shorten my coding. And I'm going to call schedule just to add a function that will schedule. And this function is going to do something pretty simple. Let's write out to the console. Running at normal priority. This will let us actually see when this gets called. One more thing, this schedule function priority, and we'll run this at normal priority. Now that function will get called when the scheduled function is actually run by the task scheduler. Let's add one more message that tells us when this gets scheduled. Now we'll take this piece of code and let's copy it a bunch of times so that we can add more tasks to the scheduler at different priorities. Let's add this one at high priority. one at idle priority. And we'll do one at above normal. We have enough priorities in here so that you can get the priority of your task right in between all of the priorities of other things running in the system, so that you can make sure that your task runs at just the right time. Now let's go ahead and run this, and we should be able to see in the console when each one of these is being scheduled and then when it's run. Let's go back to the debugger, pull up the JavaScript console window. The first thing that happened is each of our 4 tasks was scheduled in the order that it was actually declared in our code: normal, high, idle, and then above normal. However, when they were run, they were actually run in the priority at which they were set. So our high priority job ran first, and then above normal, normal, and idle. This is a really helpful tool to get you to be able to write code that makes your app more responsive and more user-friendly. Our next performance feature is the dispose model. JavaScript is a garbage collected runtime, so you may be asking why we need a dispose pattern. The dispose model gives the developer the power to control object lifetimes so that they can get cleaned up by the garbage collector. To illustrate the problem, let's use some pictures. Suppose you have a long-lived object in the system. You also have a short-lived object, which should go away when you're done using it. When you're done with the short-lived object and no one holds a reference to it, the garbage collector can reclaim the memory used by the short-lived object. However, if your long-lived object holds a reference to your short-lived object, the garbage collector won't collect your short-lived object. It now has the same lifetime as the long-lived object. However, calling the new dispose function on the short-lived object lets you break those connections so the garbage collector can collect the object on its next pass. Now let's make this a little more real. Suppose your long-lived object is your app data. Your page is a shorter-lived object that should go away when the user navigates away from it, and the list view on your page should get deleted when your page goes away. However, your list view and your data have references to each other, potentially making your list view last a long time. The dispose method on the page allows you to break those references so that the page and the list view get disposed of cleanly. And then they can both be cleaned up before your data is done being used. Let's look at a demo of how dispose might be used. I'm going to start with Visual Studio again and create another blank app. And we'll call this our dispose demo. I'm going to add to this project an existing JavaScript file that I have. That declares a control. This control, the age control, will help me calculate my age in days. Now all I need to do is add a reference to it within my HTML file to be able to use it. And an actual control should go into my page. Just like the built-in controls that come with Win.js, you can add your own controls in your own namespaces. If we run it, we can see my age control. And I can enter my birth date, and it'll tell me how many days it's been since my birthday. I'll enter my birthday and this year, and we can see that it's been 91 days since my birthday. I can hit that calculate button, but I can also change the date. That Alt-C is a global handler, and we'll come back to how that's important. Now let's look at the control code that I added in my age control. I'm defining my age control, and in the constructor, I've added several things. WinJS.utilities.add class with the WinDisposable tag will let me tell WinJS that this control is disposable, and when the page is being disposed, this control should also be disposed. And then I create my subcontrol, wire up the events, and I'm off and going. You'll notice that I'm adding a global key up listener for that Alt-C that we talked about just a minute ago. That listener needs to be disconnected from before this control gets disposed. So in my dispose function, I am disposing all of my subcontrols within the age control, including that date picker control, and then I'm disconnecting from each event, including that global listener. When my page is navigated away from, this dispose method will automatically be called, and all of my items will be cleaned up, and the memory for age control will disappear. Here's how to use the WinJS dispose model. If you create new controls, implement a dispose method on them. When you use controls, call dispose to clean up your controls when you're done with them. Finally, my two favorite features are just pure development productivity goodness. Because WinJS code is so deeply asynchronous, it can be very difficult to debug. Call stacks can be less than helpful or just plain confusing. Anonymous functions in library code can make this even worse. To illustrate, let's look at how a sample piece of async code using promises and setImmediate look in Visual Studio 2012. This is just a screenshot, but you can see what I'm talking about. In my app on activated event, I have a simple piece of promise code that calls setImmediate, and in the callback for the setImmediate, it calls into an empty function. I've set a breakpoint on that empty function. In the call stack, you can see that I get very little information. I'm in an anonymous function, but the bottom of my stack is at the setImmediate callback. There's no information that I'm in a promise or that I'm in my app on activated handler. I'm just kind of left nowhere. So let's go ahead and look at how this same piece of code behaves in Visual Studio today. Let's use the very same code in Visual Studio 2013 and take a look at it. I'll use a new project and a blank template, and I'm going to replace all the code in my onActivated handler with the very same code that we were looking at in Visual Studio 2012. I'll set a debug breakpoint in the same place, and now when we run it, we can see our call stack window has much more information. At the bottom, we see our global code and our anonymous function at the top of this JavaScript file. And then we see a series of different call stacks from WinJS, our onActivated handler, the setImmediate callback, and our anonymous function. Now we can tell exactly where we are and how we got here. However, this might be a little bit too much information for me if all of this code isn't code that I wrote. If I'd like to hide the code that I didn't write and came to me from libraries, I can show external code off, and now what I see are just the asynchronous calls and the external code links, and in darker text I see just those pieces of the call stack that are my code. This is a really great feature of being able to see both the asynchronous calls and just my code in a single view. I hope you find it as useful as I do. Today we looked at some of the many new features available for developers of Windows Store apps built using HTML in Windows 8.1 and Visual Studio 2013. You can learn about the features I didn't cover on MSDN and Channel 9.
Thanks, and happy coding!